Good evening, everyone. My name is Ishan Rao. I'm a PhD student from Indian Institute of Technology, Tirupati. Today, we are going to look for. We're going to solve three questions, mostly one from logistic linear regression, one from multiple linear regression, and one from logistic regression. So this I will be coding out the thing. Two questions I will code out the way sir has taught in the lectures, and one logistic regression I will try to show you in a different way. The ways which we are going to use in upcoming class, upcoming sessions, or in upcoming lectures also. If you are going towards week 8 or 9 or 10 session lectures, that kind of coding programming I'm going to start today. Okay, so for that I will be using Google Colab. So let me share few links on the chat here. First is the Google Drive link where I am keeping the files, data files, which I'm going to share. Another one also I'm sharing that um, I'm going to share the Google Colab thing also, which you can eventually can see while I'm writing things down. So okay, so these are the two links which I am going to use. One is Google Colab, and the other is the files which I'm going to use, the data files which I'm going to solve the problems. I'm going to solve only three problems. So based on that, we will see based on how much time it is taking. So the session may end over, or if you have any questions later, we can discuss those things as well. So the way we are going to take this today is for linear multiple regression we are going to solve a different question, but using the methodology with respect to Python methodology which is given by sir. And in logistic regression we are going to solve in a little slightly different way, which sir might have taught in the lectures, but to show you that what the upcoming lectures and what kind of upcoming problems you'll be facing in the next few weeks. Okay, so let's start with this. Before talking about linear regression and all that, the questions, I'm just importing some libraries which are quite common while solving the questions for all the three type of regressions. So let me write it out first. Import. I don't think so. Numpy might be needed for us right now. If it is needed, we will see. Pandas as PD, basically to collect the data frame. Matplotlib dot pyplot as PLT to plot the diagrams. We will be plotting the diagrams before solving the question to see that how it is look like. Cbond, it is also a plotting library which we will use to create use to generate certain plots as well as the confusion matrix as well, which we're going to see in logistic regression. And then you might have seen this stats model .api as sm. This stats model has been in this data analytics with Python course we are using mostly stats.model library for most of the purpose. Then we have some linear models that we are importing, that is logistic regression and linear regression. Okay, so and I think this would be sufficient. If anything else will be there, we will be tapping out in the below cells. Okay, so linear regression, as you might have known by this time, that it's finding the correlation between a dependent variable of an independent variable on a dependent variable. So given a question, mostly linear regression deals with two variables only. So it's the simplest of the regression we are finding. So in this, we are going to solve one question. Let's see how we will solve this. We will solving with the Ramesh Sir's methodology here. Okay, so the question one is the Brody Plastic Incorporation produced plastic belts retainer for General Motors at the Brody Plastic plant in Buffalo, New York. After final assembly and painting, the parts are placed on a conveyor belt that moves the parts past a final inspection station. How fast the parts move past the final inspection station depend on the line speed of the conveyor belt feet per minute. Although the faster line speeds are desirable, management is concerned that increasing the line speed too much may not provide enough time for inspector to identify which parts are actually defective. To test this theory, Brody Plastic conducted an experiment in which the same batch of parts with known or known number of defective parts was inspected using a variety line speeds. Sorry, yes?
Sir, sorry for the disturbance. Can you explain once again that import statement, sir?
Oh,
Why
imports.
we are using the SQL1?
Okay, these import statements are the libraries which we are going to use right now to solve the linear regression, multilinear regression, and logistic regression. For that, we are using this.
Sir, why Seaborn and stat model is okay, sir, for statistics? Why Seaborn?
I will explain that when we're going to use this C1. It is also a plot. It's also a plotting function. You can plot graphs and confusion matrix, multiple things using C1. Yeah. Okay. So we have a cooperation which try to see that in an assembly line, if they increase the assembly line speed, whether the inspector can found the number how much amount of parts the inspector can found as defective. So for that we have some data. It's shown in at this image, which line speed has been given, and the number of defective parts are found during those speeds. So for example, it will be like 20 feet if the line speed is 20 feet per minute. The inspector able to find 23 parts. If the line speed is 30 feet per minute, the defective parts are 19 or 16, just like that. So we have following this, we have some few questions. This is first question is develop a scatter diagram with the line speed as independent variable. So we have four questions, so we will see one by one. So first we have to develop a scatter diagram with line speed. So independent variable is will be the line speed here, and we have to find the number of defective parts here. Okay, so line speed will be the independent variable and number of defective parts is parts found is dependent variable on top of it. So let's start with first. So I will take that, I'll just comment out that develop a scattered. So we are going to solve the first thing. So before that we have to import the data. So data has been so I have already have this file called browdy.xlxx. So it is the same whatever you're seeing in the image. This is the same data that I have put that in the Excel file. So I'm just going to read that data now. So I'll just write using pandas. So pd.read Excel. Brody. So there's no different data here. So it's the same data that you're seeing on the screen on the image. Same data we're going to reading. I just put that in Excel format and just taking it as it is. And we just let me show the data. Okay, I haven't run this. Okay, let me run the first cell. Now all the libraries are there. So let me rerun. So if you can observe the line speed defective found, they are the column names and with the following values, 8 values. Here also the 8 values are there, 8 rows are there. Okay, so that being said, let's create the scatter diagram. for the first question. For that, you use basically a plot library, matplotlib. So I'm just using data.plot line speed, that is a column name. I have to give exact column names. Defectives found, and I'm giving the style of the points, how it should look like. Then for x-axis, the label I'm giving is defective found, and for y-axis I'm giving line speed, same as it is, and the title of the diagram would be I'm just giving as Brody plastic assembly line. I just need to show it now. So plt.show, and if I run this, so I am seeing a certain kind of pattern. So it is like that the more the line speed I'm increasing the line speed, the number of defective found is decreasing. So that's how you can see. But one caveat you have to keep in mind, that obviously while if you have to write the given any data and you put this as scattered diagram, you may find certain patterns, but don't jump to the any particular conclusion that that it will give you high r square or high accuracy in terms of that. So just keep that in mind that it follows certain things, but linear regression, that might not be that much different. So if you're seeing a kind of pattern, that might be good enough, but we will see that in linear multilinear regression, where multiple variable actually affects a lot in the patterns that you're seeing in the graph. So you should not always assume that the whatever the patterns we are seeing right now is the ultimate. We have all at the end we have to calculate them, and we have to see that we have to interpret that how the values are coming. Okay, so the first question is then, that is the scatter diagram of line speed as independent variable. Now, what does the scatter diagram development part 1 indicate about the relationship between two variables? So if you can, I just increase the font. Yeah, will fine. Yeah, so if you just observe it, it is kind of a negative slope that you're coming. Negative slope as in sense that as the independent variable that here is line speed is increasing, your y variable defective found is decreasing. So it's not, it's a negative relation. So we just have to see that whether it's how we can what coefficient values of beta 0 and beta 1 will be found in this. So that's the interpretation of this will be that it is a kind of negative correlation is happening between, as you increase the line speed, defective parts you will able to identify is less. Now use the least square method to estimate the regression equation. So here I'm going to use the same method of how Ramesh sir has taught in the lectures. So I will use the OLS method itself. So for that, let me write. So data, that is the data frame that I am having. In that I will create a line. Just let me see line speed f is okay. So I'm storing the each column variable in a particular variable. Each column, that is line speed, into a particular variable. So line is for line speed, and defect is for defective found. Okay, now one more thing that we usually do, and this statement, that is sm dot add constant, and then we put line. Okay, so what we have done is we are putting add constant line. That means it will create a constant of row of 1. So why did it do that? Because it is it is helping the algorithm to find the co-intercept at the y-axis. If you don't do that, it's still a choice. If we don't do that, still mostly it will work out, but it is usually preferable. So I don't know actually mathematics about that, how you keeping the constant one, a column one rows will give you a different kind of output, but it is generally preferable. Maybe in the next slide I will try to read more in the mathematics of that, and I may explain you. But this is usually usually considered that you should add constant function to create a constant of a column of ones. Okay, now I will just do sm.ols, and then I have to give the first as the dependent variable and second is the independent variable. So in this, defect is the dependent variable. Let me write it down here also. It's dependent variable, and it is line will be independent variable. So if you're using OLS function, first you have to give dependent variable and then followed by independent variable. So the OLS will give you the least square function, and then we will use fit function. So it will provide us the actual results of all the values. So if I just do result.summary, it should give me the answer. Okay, so based on the data that we are having, we are seeing that the intercept here is 27.5 and the slope is minus 0.3, that is a negative slope. Okay, since it is a negative slope here, so we can say that whatever we have seen in scatter plot is as a negative relationship between line speed and defective is correct. If it's a positive, if a coefficient slope is positive, that value is positive, that means that it has a positive correlation with the dependent variable. If not, it is a negative correlation. Now in this you can also see the R square value, that is the goodness of function R square value and adjusted R square value. It is around 84%. So for 84% of the variability, it can be explained by the line that has been created by this regression function. And followed by you have F statistic and T statistic, P statistic, which is I'm not going over right now, which is something has been discussed thoroughly. I'm just showing the coding aspect of it right now. Okay, so now that this being done, now the fourth question is, so this is how you can find, for using least square method, you can find a coefficient of line speed and this basically using OLS method. Now the fourth question is, predict the number of defective parts found in the line speed of 25 feet per minute. Now in this fourth aspect, we have to create a linear regression model. Till now, if when you are using OLS, we are just creating, we just found somebody using least square method, but we haven't created a model which can predict. So in this case, we will create a model and we'll just see that, see here in the data, we don't have any value of 25. So it is asking that predict the number of defective part will found if I have a line speed of 25 feet per minute. So let's do that as well. Okay, so first we need to create a linear regression model. Build a linear regression model, which will be used using sklearn library. So first again, I have to define the independent variable x data and y data. So line speed is my independent variable. Now what I'm going to do is I'm reshaping this value to make it as an array into a form which can be read by a linear regression function. Similarly, for y also, I'm reshaping the values which has been stored in a typical array format, such that the linear regression function can understand whatever the data has been given. It's just changing a format. Nothing difference is there in terms of value. Now I will create an object of linear regression, and I will fit the value using x and y. So if I do this, I will also if I do this, I will get the intercept value and all that. So for that, I just need to write reg dot intercept. Its zeroth aspect, zeroth position value will give us, and reg dot coefficient, that is the slope value, that this will give us. Okay, I have got some error. Okay, I have written, instead of square brackets, I should give the parenthesis here. Series object has no attribute value. Okay, let me see, it's data only. So data dot line speed value dot reshape. Okay, I should give values instead of value. Okay, so here we are getting output of 27.5, and the slope which is given in array format is 0.3 minus 0.3, which is similar to what you can see here in constant as well, that is 27.5 as a intercept and minus 0.3 as the coefficient. Now one more thing I have to tell you, that in most of the scenario you might find the same values using sklearn on the OLS library, but there will be some instances where the value you find using different libraries might be different. Okay, so mostly not in linear regression, maybe in logistic regression, based on the amount of the value of e they take. So I will talk about that as well. But if you see that any not much drastic change between whatever the value you find using OLS method and the linear regression, logistic regression, you just accept that as a value, because it, based on the values they take in the background, we don't know actually till what extent they take the values. Okay, now now we have created the linear regression model, we just now have to do is predict it. So to predict it, I just do reg dot p, because reg is a linear prediction model, and in this I have to pass the value of 25 feet per minute. Now if you observe, I have given this value in two square brackets, that means the linear expression regression model is expecting a 2D matrix. Since we don't have a 2D matrix, we have to pass the value using this, using the double square of 25. If you give this, it will predict the value. So for if the line speed is 25, assembly line speed is 25 feet per minute, then the number of defects which the expector might found is 20 defects. So that's what we can interpret from there. Now we can see this. We can see this by plotting a regression line on the on that data as well. So let's make a regression line here as well. So plot the regression line. So here I'm using same as matplotlib library. So again I'm defining line speed defects found pd.figure. Now if one of you has asked that what is the use of Seaborn Seaborn as a library. It is used for plotting function. So what it will do is, I'll just show you the output directly. Using matplotlib also you might be able to do, but this is another way using SNS. Here you can see, you can try to fit whatever the regression model that you have found, you got from there, you try to fit that with the data points that you are having. Okay, so fit reg, if you're saying it's true, that is it's fitting the values, it will take that. So reg plot is the regression plot, is specifically made for a linear regression. So we are attaching the regression plot with the matplotlib here. X dot now plt dot scatter color red. So whatever the line will be there, I will consider it as a black. So that's why the black line will be there from using the regression plot sns.regression plot function, and the matplotlib scatter function will give us the actual original values with the help of red dots. Okay. Now, if you have seen this grayish area, is the residual area that you might have read in the concept, the nominal residual, and the two concepts are there, right? With respect to this, I forgot the exact name. Um, it will be, it's a residual plot. If you look at the residual plot, you get this value. So I forgot the exact name of what we call it as. Okay, now in this, if you have to make certain more changes, the changes like if you want to say that if whether actually at the 25 value you can get the value of 20 or not using the plot, what you can do is you can tweak a code a little bit. So let me write the code in different cell here. So here I just has to do since I know that for 25 line speed I'm getting the 20th 20 defective founds. So since I know this value, I will try to put that in the in this graph. So I will just add, I will first add a point at those values. So 25th from the x-axis, 20 from y-axis, and color of that point will I'm giving as yellow. And then I'm giving them a dashed line such that we can see that they are exactly to what we are seeing, perfectly perpendicular to the exact value with x-axis and y-axis. So 20 0 20 line style dashed similarly plt dot horizontal line 20 to 25 line style dashed. Okay, if I do this, so if we can see that using the dash plot line, we can see that it's exactly perpendicular to each other, that is between 25 and 20. There's a yellow point here we can see. I just little bit zoom more. Okay, for this yellow point you can see the dash line as there. So we just created two PLT V lines and H line, and we have put the scatter line of yellow point using PLT dot scatter on the line. So we made that point and we're just seeing that whether these values are correct or not. Okay, so that's how you can solve a typical linear regression question here. Not much to do. Mostly you have to remember the function names also, but the only where you can play with is the way how you want to represent the data. So if you represent data in a certain way using the plotting libraries, there you can play a lot of ways. Okay, so that's the one question that we're going to discuss for linear regression. If we have anyone has any question, please ask. Otherwise, we will go to multiple regression now. Anyone has any question? Okay.
Excuse me, sir.
Yes.
Sir, how to rememberize the codes for the different plots or?
Okay. For plots, it's little bit practice, not that much. You will going to use plt.scatter function a lot. Okay. And if you want to highlight a light, sns.reg plot. So whatever the extra that I have done here, that dotted lines, it's not something you might have to do. No one will ask for that. I just show you for the demonstration purpose. Okay, just 3-4 times if you do, you will remember it. Like for like the code for plotting is same for all different kind of regressions or any other things. So plotting function doesn't differ. Only where you have to remember a little bit is basically this lines,
So model fitting lines.
model fitting lines, and using of which function you're using. In this case, like sm.ols, that is one way. Also in that you have to remember which one will come first. So like defect has to come first, that because that's a dependent variable. Line is independent, it has to come next.
Okay.
So those are the things, but it comes with little bit practice. It will You might remember. Yeah.
Okay. Okay. Okay.
Yeah. So again, I posted the link of this Google Colab notebook. If anyone want, they can check directly from there as well. Okay, if no one has any other question, I'll start with multiple regression. Okay, so multiple regression is basically an extension of linear regression with multiple variables. Here we are taking 3 variables. So let's see what the question is about. So the multiple regression is the Conde. Okay, so one has asked the question, I guess. What type of question coming in exam? Okay, so the questions which you have seen in your assignments, the question will be related to that. Maybe the values will be changed max to max, or also check the theory, the PPTs that the professor has given to you. If you use that, that will be more than enough here. But do all the assignment questions. That's the key. Sorry, I can't hear you. Can you type out?
Yeah, am I audible?
Yeah.
So my question is that whatever the question in the assignment,
Mm-hmm.
in that sometimes there is a coding portion, and
Mm-hmm.
on the basis of that coding portion, we get the result.
Okay.
Yeah.
Yeah.
So at the time of examination, so what only the MCQs are there.
MCQs will be there, but they will give you certain kind of a data where you can type it out, because, like for example, the logistic regression kind of questions, you can't solve it by hand or
Yeah,
any.
yeah, that's why I'm
Yeah, so those questions you can't solve it by hand. So that's why you need to write the function for that, and you have to solve it. So uh, that's how you can do. They will give the kind of editor where
okay,
you
okay, yeah,
where you can type all those things and get the answers.
yes, thank you.
Yeah. Okay. Let's start with multiple regression. Uh, so, so the Condé Nast Traveler Gold List provides rating of top 20 small cruise ship. The data shown below are the score of each ship received based on the results from the Condé Nast Traveler's annual reader choice survey. Each score represents the percentage of respondent who rated a ship as excellent or very good on several criteria, including shore excursions or food or dining. An overall score was also reported and used to rank the ship. Overall score is how good the trip was in that cruise. The highest ranked ship, the Seaborn Odyssey, has overall of 94.4 score, and the highest component of which is 97.8 for food or dining aspect. So out of 100, they have given 97, almost 98% for the food. Like they like the food. 98% people like the food a lot. So the first question, determine an estimated regression equation that can be used to predict overall score given that the score for shore excursion. So for the first question is they're telling that given overall score, that is a dependent variable here, if we have only shore excursion as it is, nothing more, then what will the how we can predict. So we have to find a regression equation for that. So we will start with that. And the second question is, consider the addition of independent variable food or dining, develop the estimated regression equation that can be used to predict the overall score given for the score for shores and food dining, score excursion and food dining. So if along with shore excursion, if we include the food and dining variable as well, how much the regression equation will improve. So we have to see the R square value here as well, and we have to then we have to predict the overall score for a cruise ship with shore excursion of score 80 and food dining score of 90. So they are asking us to predict that if we give the shore excursion value of 80 and food dining score of 90, what will be the overall score of cruise ship. So for that we have to create a multiple regression model for that as well. Okay, so one by one we'll solve this part using programming. So let's start with this. This is the data that we are having with 20 ship names and with the overall scores, which is the dependent variable here. Shore excursions and food dining is the independent variable. So the same data I have put that in cruise.xlsx, that Excel file that we are having. So let me okay, the first question is that we have to find a regression equation given we have only one independent variable, shore excursion. For that, first we have to read the file. So the file name is a cruise. So let me read it. I have already uploaded that file in the Google Colab notebook, and I have shared the Google Drive link where the file exists. So let me read this using pandas, and let me show you what the data look like. Okay, so same values, ship name, overall score, shore excursion and food dining values. All values are there. Now one thing I will do is right now to show you this, that just to plot that figures for these datas for one individual variable with respect to its dependent variable. So first let me write it down. So given I have a shore excursion as my independent variable, I want to see its relationship in using the scatter plot diagram to see that how whether it's a positive, negative, what kind of relationship I can find out with with the overall value. Overall, I wrote the spelling wrong here. That's why here the spelling is wrong. That's why I'm using overall, the with one L. Okay, so I have taken from data frame, I have taken these two columns, and I'm going to scatter that, and the color of the points will be green. Okay, and I'm just I'm just printing the labels, what will be written on the y-axis. So it will be overall rating of the cruise, and for the x-axis it will be ratings for shore excursion, and the title of the plot will be simple linear regression, not multiple, simple regression with shore excursion, because we are taking only one variable at a time. So if I run this, so we can say that as the rate of score shore excursion is increasing, our overall rating is also increasing. So this is a kind of positive correlation we can see, because if you put a 45-degree line or any different kind of lines, we might find a positive correlation. So that is, so it is with shore excursion. Let's see that what is the relation of overall rating with the food and dining aspect. So I'm just copied the code from wow. I'm going to change certain values, that is instead of shore excursion I'm going to add only food or dining column. Overall will be the dependent variable, it will be in y-axis, and I'm giving the color of that points will be as red. I'm just changing the labels. Ratings for food and dining at the x-axis, y-axis will be the same as overall rating for the cruise, and this title of that thing also I'm just changing. If I run this, okay, so here what kind of relationship can we say that? Because it's not, it might be increasing, but it's mostly static in most of the point. That is around 90. It is at 90 percent of value between 85 to 95. The rating is almost is starting from 86 to 92. But there are some instances where as you increase the food dining, the rating is increasing, but it is not as uh, evident from the graph as we can see from the shore excursion. So while you're going to solve that, just make an observation that once you plot a scatter diagram and you had some idea about the relationship it will look like, look at the values that like right now we are going to find a regression value with shore excursion. So see that if we add food or dining variable as well, how much the improvement will be we can find in the uh, regression model or the regression equation, because here we can't see a proper increment in the value, because most of the values are lying around the region of 90 in the for the food and dining. So we will see that how we can interpret those values as well. So once we have this, I'm just what I will do is I will just plot both the value, both this independent variable, that is food and dining, with, and I will plot it with respect to overall rating. Ideally, I should make a 3D graph, but Matplotlib provides 2D support. It provides 3D support also, but for that right now, I don't think so. It's necessary for you people to look at it. So how we can plot that diagram as well is just copy certain things and okay, so I put the scatter plot diagrams for individual shore excursion overall and food dining overall like that, and I'm defining the figure here. X label will be the overall rating, and say Y label will be overall rating and rating, and X label will be combined ratings for food dining and shore excursion. So shore excursion will be, points will be, you can find in green, and food dining points will be find in red. So it will be, this will be the multiple regression which we are trying to show in a 2D plot. Okay, so if I just run this function, so we can see that it's a kind of mix match for both the food dining and the shore excursion variable. It's quite jumbled up mix, and we can't properly estimate because of the food dining variable that's a positive relation, or we can solely say it's not a negative relation per se, but we can't even say it's positive relation exactly as we can see as evident for the shore excursion points. Okay, so that being said, let's try to write the code for finding the multiple regression equation. So first we have, for before finding that, the first task that the question asked us is to estimate the regression equation given that I have an independent variable of shore excursion. So first I have to do simple regression on the type of data that I am having. So I'll just like estimate linear regression. Linear regression with only one independent variable. In this case, it's shore excursion. Okay. Now, okay, so for that, we can use OLS function directly from how we have used here in the earlier question. Let me find this, not this, this. We can use this way. I'm going to show different way of writing also. You can use OLS function directly in this way that we have seen for the linear regression function. So again, OLS function is the one which will find for you the least square. Using least square method, it will find the linear regression equation. So whether it's a multiple regression, linear regression, we use least square method to find a regression equation. So that is one way of writing it, but I will use different way, which Sher has shown also uh, in the slides. So I will just use multiple regression. It's not actually multiple regression, but I just write multiple regression like that. OLS formula overall title Shore excursion. So the formula will take these overall and shore excursion values directly from the data. So we are defining the data as TF2. So from these values, the formula will automatically will take shore excursion value. Now we just have to do a fit function for this multi dot rec dot fit and fit2 dot summary. Okay, so here OLS is not defined. Okay, so I just have to do maybe sem.ols. Okay, again I am finding some issues. Missing one relation point and OG. Okay, okay, subtype if like this is happening, what you can do directly is stats model. I will directly use API import OLS. If this certain kind of equation, sometimes you feel like the OLS function is not working, which sometimes happens, you can use the stats model formula.api import OLS. If you do that, you can find this value. Okay, now once we get this regression result value using least square method, okay, so we have an intercept at 69.2998 and the slope value is given as 2348. We have a r square value of 498 and adjusted r square is 460. Now considering this, we can see that the r square value, the goodness of fitness, the fitness function is less than 50%. So the shore excursion in itself is not able to help in identifying good proper overall result value. So as the second question demands, from here we have to use we have to see that if we add independent variable of food and dining, how much the regression equation will change and how much the better the equation regression equation will become. So let's add food dining values also in the regression equation. So to do that, I will just take this value I'll just give different name here, so multi-track 1 maybe, and here an OLS formula along with overall a shore excursion I will add food dining as well. So it will take these two variables, shore excursion, food dining variables, columns taken from df2, and also instead of writing fit as separate line, you can directly write fit here as well. If you do this and if you do multiple regression 1 dot summary, okay, so now we got the intercept, our intercept has been changed, and for our to both the independent variables we found a slope that is 2524 0.29 and 0.2482. But the interesting aspect is the R square here. That is the goodness of the fit that we are finding. It has been increased after using the it has been increased by almost 30%. Earlier it was around, say, 20%, or earlier it was like 0.489, that is around 48% or 49%. And after that, the ask value, after adding food dining as an independent variable, it has been the goodness of the fit has been increased by almost 20 percent points. That is around 73.8, approximately 4% here. So, but if you look at directly at the scatter plot, you may not exactly find a positive area of the rating of food and dining. So it's not that much scatter, and this we can't exactly say it's a positive correlation. But in the equation, when we are adding this value, it is this has been increasing the multiple regression equation. So it is increasing the goodness of the fit. So that's why sometime when you see the scatter plot and the equation, basically the R square values, it tells a different story, that how a particular adding of one independent variable, how it increases the goodness of the fitness of a equation. Okay, so that being said, the third question here is we have to predict the overall cruise ship rating for shore excursion of score 80 and a food dining score of 90. So we have to create a multiple regression model here and use that model to predict for the values that is given there. So I'll just write it down here. So the for shore excursion, my values was given as 80, and for dining the value was given as 90. So I have to predict this using multiple regression. So for that I will write a different code here. So here, since I have multiple regression, so df2 where our data is stored, I will have both this independent variable taken as a x, and for dining, then y will be the dependent variable, df2 overall, then you just have to do, since multiple linear regression is also linear regression, so we just have to deal with this x variable, like how independent variables are present. We just have to change this value. Other thing, most of the things we don't have to do, and we just have to do reg.fit, and I'm just going to find the intercept values. I will just see that whether the intercept values that has been found using this model is being different from the OLS function that we have used earlier to find the regression equation. So since we have two independent variables, so it will be given as a 2D array. So I have to 0 0 and reg dot quotient for 1 0 1. If I run this, some error is coming. Okay, so if you find this two position arguments of x and y, so what might be happening is that any of one of them is not uh, in a proper format using which linear regression can take. So we just reshape it. So first, usually you start with the single variables that you are taking. Mostly in this case is y, because the x variable is already a 2D. It will be a 2D matrix, but y is a single matrix. We have single matrix or single array, we can say. So we have to just reshape them. Okay, again some values are problem coming. Where the fit problems coming? Oh, I haven't passed any values, sorry. Okay, so we found for intercept it is around 45.1779 something, and here it's using the OLS function that we have found, it's 45.178. So it's almost near. So this is might be a more extendable that this linear regression is found. Similarly, for shore excursion, the slope value is given as 0.2529. Here also it's like 0.25289. So we can round off the value and we can find the exact thing. Similarly, for foot dining, it's here is to 0.24818. Here it's 0.2482. So we found the almost same intercept values and all that. So we have built the regression model for this, multiple regression model for this. We just have to do predict. So for that we will use a predict function, and mostly the predict function asks for a 2D array. So we are giving two square brackets, and in this we are passing two values, that is the shore excursion value, that's first variable independent variable, and the second independent variable is foot dining. So if we do this, we're getting overall cruise value as 87.74636008, kind of like that. So given I have a shore excursion of 80 and foot dining of 90 value of those scores, the overall cruise ship rating will be around 87.74. That's how we can find it. So again, understand that here using OLS regression results, we are just finding the regression equation, not the regression model. But using sklearn functions, we are making a linear regression model, and using that we are predicting what the values that we are having here. Okay, so this is about the multiple regression quotient. I think it's already 7, so we will take a break of 10 minutes here. So till now what we have done is we have taken mostly the way how the sir has solved the quotients, but the quotients here are taken from different books like that. We have solved for linear regression and multiple regression. Now in the upcoming the next part, we will see the logistic regression, one way of how sir has solved with the same question that sir has taken in the slides, and one different question that we'll use to predict diabetes using logistic regression classifier. There we will try to see the concept of confusion matrix and all. Okay, so if you have anyone has question, please please let me know. Please use of OLS function, it is for this OLS, I don't remember the name of O, but the LS is for least square. This use for finding we use least square functions to find the regression equations for the for linear regression and multiple regression. Okay, if we okay, so I can use the paper pen method for this, but this data are very small. That's why I'm not. But also the calculation will be quite high if I use these methods. That's why I'm using it programming, because you might have to solve this type of quotient using programming. I hope you understand. You please look at the code. It's not like I'm not expecting you to understand every part of the code just like that. You spend some time, you may tweak with them. You might be able to understand slowly. I'm just showing you a part of it, just like this. Because in the exam anywhere, you can't use pen and paper to solve these kind of questions, because you have to solve multiple things. You can't find the mean, the variance, and all that to find the regression values. So intercept and the first you have to find the intercept value, then you might have to find the slope value, then f values, r values. There's so many values that you have to find. You can't use pen and paper in that point of time. So you have to use code in those scenarios. So you have to practice those these codes, and slowly you may get habituated to it. Any other question?
Sir,
Yeah.
right now we just built a model, correct?
Yeah, we just built a model.
Okay, so but this model is perfect or not? For this, we have to also check the residual plot.
Yeah, we can check that as well. But for that, yeah, we can do that. We can use the algorithm given by sir, that if you see the lectures, he has given the certain values, like using.
Sir, if you able to give a glimpse of the residual plot, so that will be better for subject.
Okay.
So that model built is perfect or not, we can means just verify.
Okay, okay. For if we can see here, okay, I will do that. Maybe not in this class, maybe another class because I have to check the how to code it properly. Uh, and for multiple regression, I can't show it because I might have to use 3D plots. Maybe I will try to do that next class, how to do that using 3D plots because the more the number of variables, the more dimensions will come. So that dimensions I can't show directly on the screen. But one thing what you can see here is the residual plots that you're saying. Uh, it can be observed using SNS dot direct plot as well. The highlighted gray part is actually the residual plot. But again, if you want to know exactly the values of those things, I didn't touch those things because the algorithm is already given by sir in that. But if you want, again, maybe in next class, I will touch that topic and I will try to solve those things.
Okay, sir.
Okay, because the majority of difference will be, I will check the whether we have an exact direct function for this or not, because when I checked after looking at the lectures, even I haven't found the residual plots exact function. So what sir has done is whatever the mathematical equations are present to find the residual plots, he just converted that into code and he just run those things. But I will check that whether we can do directly without much hassle or not. I will check and I will let you know by next one.
Okay, sir. Okay, sir. Because this residual requires the means
ANOVA table kind of stuff, right?
yeah.
Yeah, sure.
Street.
Yeah. So at 7:10 we will maybe start. Maybe 7:10 or 7:12 we will start the uh, session again. Okay. So question: if I'm doing a project machine learning, then what topic would we do better? Please suggest me. Uh, okay. In machine learning, there are different type of models are there. So I can't suggest which model to use and all. It depends on the problem statement you are having. That kind of problem statements, if you don't know, you can go to Kaggle. It's a very good website where there are lots of ML related challenges will be there, and you can use multiple machine learning models from basic regressors to classifiers to the we might use the neural networks as well to solve those things. So I will just show you the Kaggle stuff. Just like how you do coding practice in multiple different platform, similarly there are a lot of competitions and models and data sets. Their tutorials are also present here, so you can look at that. So it's a free, these numbers you are finding is maybe the price that people are giving if you're able to find better models for that. Okay, so you just try these things out. You get much more idea, better idea to how which kind of machine learning problem you might have to solve. Any other questions?
Sir, in confusion matrix, please explain three class confusion matrix, sir.
Three class confusion matrix. I am okay. So I'm assume that no one knows confusion matrix. That's why I haven't
No.
you
While explaining confusion matrix, please use
that
that class.
three class confusion matrix.
Yes, yes, sir, yes, sir.
Okay, I will check that based on the problem statement. If I can do that, I will use that for sure. Otherwise,
Thank
maybe next lecture I will do that.
Okay, thank you, sir.
Yeah. Can we use core data in NPTEL? So the NPTEL will have its own exam portals. So there they might give you code editor. You can't use your own editor because you're going to test centers right there, and they will have their own system. So ideally, since it's a programming related data analytics with Python, they will provide a code editor for sure. Give me 2 minutes. I'm just come back. We start the session at 7:12. Okay, I think it's on 7:12. Let's go there. Okay. we'll start now from logistic regression. I will just give a brief of what sir has taught in the class with logistic regression. I will show you the one of the ways that how we can find the logistic regression uh, uh, equations using certain things, and we will like how sir has solved, and then I will take another question, I will try to create another class logistic regression classifier based on diabetes data set. Okay, now if you have remember, there's a question of are there that there's a store called Simon Apparels the where the management wants to try that if they want to give a coupon of $2,000 or above off certain kind of offs. So which kind of customers they should give those coupons. So based on that they have certain data. So they are checking that on an average yearly how much a customer is spending in terms of thousands of dollars in that Simon's Apparels. Whether they have second is whether they have a second variable is that whether they have a credit card or not. Third variable is coupon, so whether we should give a coupon or not. So it's a binary class. It's a discrete value. Similarly, card is a discrete value variable, and spending is a continuous variable. So in this question, the spending and card was independent variable, and whether to give management is saying whether to give a coupon to that customer or not, that it's a dependent variable. So we will use this spending and card value to find whether the person is eligible to get a coupon or not. So that was the question, and this is the data. Around for 100 customers they have the data uh, for in which card and coupon has the discrete values. Now if we just plot uh, the if we plot the coupon column and the spending column, only these two values are there. So let's see how the relationship look like. So either the relation is a 0 and 1, since it expectable because coupon is a dependent variable and spending is a independent variable, and since we are doing a mostly a kind of classification, the value will be either 0 or 1, nothing in between. So it will kind of form of S-shaped curve uh, kind of thing. I can't show it here, but it will be form a kind of S shaped curve. Okay, so that's how the data look like. So how sir has solved that in this question is they've taken directly this independent variable, that is card and spending, these two values, and dependent variable is coupon. Then they use this import stats.model.api as SM, and they use add.constant is just to add the constant column for the independent variable such that it can find the intercept value. Then it use the stats.model use the logit function to create a logit function in which first we are giving a dependent variable and next you give the independent variable. Uh, so independent variable is a combination of two values, that is card and spending. Once you got this model object, you fit this value, fit this model using these two values, and based on which you find the result. So the result summary will be okay. So for logistic regression, one thing you have to do understand that it's not like it find the value at only one time. So it do multiple iteration to reach to a highest peak value. Okay, so I can't show it here, but it is like while converging the values for the logistic regression, it will attain a peak point at certain observation. After that it will go down, so till it attains a certain maxima, there it will stop. So based on that it will give us the value. So here the constant here is the intercept is 0 minus 2.14. For card the slope value is 1.09 and spending is 0.34. Now this thing has been interpreted, instead of ask her, we look at the log likelihood value. The less the value the better. The so if you have more positive value in this, consider that it's not a good fit model. Okay, since the value is very less because it's getting very negative, so we can consider it's a good model. So we usually look for this log likelihood, and then we see the z-test to see that how much influence each independent variable has on the dependent variable and all that, and we have to do a p-value test. So that's generally how we do. And to predict the value of of using the independent variable of card and spending, whether to give a coupon or not, what we'll do is we use sklearn. From there we'll import linear module. Same at the independent variable we define the columns, that is card and spending as an independent variable. df3 coupon will be the dependent variable. So using linear model we'll call the logic regression. This model will call as an object. This object will call the function called fit, where we're passing this independent and dependent variable values. Once it fits, it gives the intercept value. So let's run intercept and coefficient values for the independent variables. So if you can see that here, the value here for intercept is minus 2.0.0067, but in the earlier function that we found using stats model function, where we are finding coefficient of 0.1464. So values are differing, but not to that extent. It is coming because of the this difference is coming because of the value of e, because if you remember the equation of this logistic regression, we have e raised to beta 0 plus beta 1x beta 2x and all that divided by 1 plus e raised to beta 0 plus beta 1x beta 1 x1, kind of like that. So e can be taken to multiple decimal. It's an irrational number, so you can take any different to any extent decimal numbers based on which the calculation might differ, not to that extent but little bit. Similarly here for card spending we are getting the value of 0.9178, but here it's 1.09. It's all depend on the what is the value of e, the exponential value that you're taking here. Similarly for spending, here it's 0.3298, here it's 3416. So a little bit difference we can observe in those things. Mostly you see this kind of difference only in regression equations, logistic regression equations, because of the parameter e. Now if you want to now since we got the log r as a logistic regression model, if you want to predict that if I have a spending of 3.3k, that is $3,300, and I have a credit card, then what is the probability that I will get a coupon? So I will get the answer is 1. That means 1 is in the coupon value. If 1 is there, that means I am getting a coupon. 0 means I am not getting a coupon. So in this case I will get the coupon. Okay, so that's how you usually do for logistic regression, with the way that how using the stats model way. Now what we will do is we will take a different question, and here instead of predicting anything, what we'll do, we'll try to train the logistic regression model directly instead of creating a regression equation here. We'll try to train it using the data that we're having. Based on data, we will test its value with the same. We test the logistic regression model with the data that is already given in the data set. Okay, so what we are going to do is we have a from Kaggle I have taken this diabetes data set. So I have already it names at diabetes.csv. So I will show you how the data is look like. So for that I'm just, it has multiple I think 7 to 8 variables. So I'm just, and it has very different names. So what I'm going to do, I'm just going to give the simple names for that. So what I will do, I will just give certain names to those values. I will show you how it is. Just let me write the column names for this first. Skin, insulin, BMI, . pedigree, I'm just giving an alias name to them, so you will understand why I'm doing. So I will just load the data set here. So I'm just giving, it's a PIMA data set for Indian diabetes. So I will do, it's a CSV file that I am having. I'm taken for kaggle.com that I've shared the website link with you in the break. None. Names equal to all names. If I run this, it's a big data set, so by the time it do, I will just do pima.head. Okay, my runtime has been disconnected. Just a minute, it will get upload. The files will be there. Yeah, files are there. Initializing connected. Okay, this has been loaded. Okay, so I have 8 variables here in total. So what I have done in the first line is I have columns with different names, that is pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, function, age, and outcome. Outcome is that whether I have a diabetes or not. 1 means diabetes, 0 means not a diabetes. I'm not a diabetic person. So I have this few parameters. Along with this, I'm getting an output. So I can remove this, but for the sake of my understanding, I've given the different column names for them so that I can use them properly while dealing with this, building this logistic regression model. Now once I have this, at the 0th row I have this variable, this function, this column name. So what I will do, first I will drop these values uh, and I will replace them, and already I have replaced them with the column that I am having, that is pregnant, glucose, BP, skins and all. So I will do pima.drop. I will remove the first row, so I just have to do pima.index 0, and axis is 0, which tells it's a row, and in place is 2. I have to do in place. And if I do pima.head, so some data processing we are doing right now. So as you can see, we have removed this 0th row from here. Okay, now once we have this, now what we have to do, we have to select some features. So right now I just know that I have I have to make a diabetic, I have to make a logistic regression model to find whether a person is diabetic or not based on the certain values. To do that, I have multiple features here. So instead of selecting all the features, I may take few features and I will take the label outcome, that is the outcome. 1 is diabetic and 0 is non-diabetic. So I will select features for that, and also split the data set into features and target variable. So what features I'm going to take here is, I will take the value of pregnant, maybe glucose, BP. This includes insulin. I might take it, but I'm not taking right now. The skin variable. So I will remove this value from my logistic regression model. Then I will include insulin, BMI, body mass index, pedigree, and age. And my target variable will be label. So let me write all this stuff. So feature.calls. So it will be like, if the person is pregnant, I will take insulin, BP, age, glucose, BP, and pedigree. So for this X features, that is my independent variables, I will select feature columns and y, that is my dependent variable, I will take pima dot label as it is. So I will write it as target variable. Let me run this. So I have x and y already in place. Now what I have to do is, I'm not going to find any logistic regression equation. So what I will do, I will use the concept of train and testing. So for that I do splitting of data. That is, I will split x and y into training and testing sets. So for that I will use sklearn library, in which model.selection import train test split. I will use this function directly. So in this, so we will have 4 variables from here. So we will have x train, y train, x test, y will small, y test, and train test split. In this I will add x value, that is independent variable, dependent variable. I will use a test size, that how much the test size should be like. So if I'm getting 25%, that means out of 100, 25% of the values will be, rows will be taken as test. And I'm giving some random state here. We can give any random state to take the values randomly from the value. So what does this means is, I will create 4 variables. So for training a logistic regression model, I will take x train and y train. That for given x values, I will have a certain y value. So I will gather directly from x train and y train. And for x test and y test, what I will do is, once the model has been created, I will test using the x test value. I will give them input of x test, and I will predict certain values, and then I will compare those predicted value with the y test. I will show you what we are going to do that in the next state. So let's split the data. Now we have to do model development here. Model development, that is logistic regression. And we will do prediction over that. So I think I have already taken logistic regression directly. So what I will do is, I will instantiate with certain values, instantiate the logistic model with some parameters. I will tell about these parameters. So I will take a name of logreg here. So if I do logistic regression, there is something called as solver, LBFGS, and max iteration I'm giving as 1000. Okay, so these are some parameters. So what are these parameters? For this, either you can directly, I think if I hover here, I should get some values. Okay, so LBFGS. Okay, so they are some L2 localization models. So a kind of optimization might be there, might be doing while calculating the logistic regression model, because it's very computation extensive. Logistic regression is very extensive, because we are using the same exponential values here for that. So you can read about this maybe in different ways. So different kind of solvers are available, that is linear, Newton CG, SAG, Saga, or LBFGS solver. By default, LBFGS is the by default thing. Now iteration is, while solving, since the logical regression is, we have to find the maximum value after. So the curve will be in certain way that it will reach to a maximum point. After that, it will start going down. So we have to find that convergence value where we find the maximum value. Once we find the maximum value, the the iteration will stop. But we have to give higher number of values because we have large amount of data here, maybe around 100 hundreds of data. Let me check how much data we are having here. So we have approx 768 datas. So we have that much amount of data, that's why the iteration value we are keeping it high. Now I just have to fit the model. So for that I will do logreg dot fit. I will pass the value xtrain ytrain, and I will give prediction value. So I have to predict also. So for predicting, once I get the fit value, my model will be trained usually, and after that I just have to do log reg dot predict x test. So I will be predicting, I'm storing the value with y prediction value, and I will compare it with y test value. So let's run this first. Let's train the model and let's predict as well. Okay, so I have some error, x train y train. Y should be 1D array, got an array shape of 197 and instead. Okay, so where we get wrong here, x train y train. Okay, logred dot fit. Here it is normal. X dot label is also available. Train by train. Okay, I will just search the Stack Overflow here once. So once you might not able to do that, but don't worry, you may not get this kind of you might not have to do this much amount of things. So I have to do reshape here, I guess. Okay, let me, then where should I reshape here? Values, reshape this one. Again the problem is coming. Logred dot fit x train y train. Okay. Just a minute, I'm just trying to figure out what the problem is here.
Yes, sir, no problem.
I have reshaped also. Yeah, so reshape is not as helping us. So from scaling, okay, let me see whether I have a skeleton model, but let me write. Okay, let me see the other place where I have written this properly. This is another notebook where I tried different stuff for coming here.
Excuse me, sir.
Yeah.
Sir, the travel function is used in browser Ramesh sir class. In that LReg X train, y train dot travel function.
Travel function. But I did this code without using that.
Okay.
So I'm just trying to understand where I got wrong. Okay, let me see here because the code is almost same. Only this error didn't came earlier. Okay. Something wrong here. Okay, so what I will do is I will try to run code here, which I did earlier. Let me upload certain files. Okay, from here it is. Okay, I was just checking that how the values will look like if I separate the feature values at that point of time. So I got this value for 768 rows. I got for the 7 parameters, or sorry, 7 parameters that I'm having, and for label I'm going like this. Then I did the same splitting of data, and
Label type is object authenticate matrix
no, here it is working perfectly fine. If I'm running this, here it is not showing the same problem. It's actually the same code, nothing much has been deferred here. So here it is running perfectly fine. Okay, I will check that what is the problem with that thing. Okay, so once you get that thing, you will find some values and you store that in bipred. Okay, and based I will just if I have to print it things, okay, I can write one code here. I will just do for I in range 5 print x test I y test. And y-pred. So this is the predictive value of using logistic regression. So first will be the x-test value, second will be y-test value from the data set, and the third will be the predicted value that we got. If I run this for 5 samples, I am getting some key error. Wow. Okay. How much time do we have? We have 20 minutes. Okay, let me figure it out. Key error is 0. Okay, if I just do y-pred, okay, for 5 prediction value I'm getting certain values, Okay, I should not do this, but I thought I will be able to do. Okay, I have some issue with y-test. Okay, I will check this later, but with y-test I have certain range of values. So let me delete this. So once I got the prediction values, what I have to see that how much better it is able to predict my uh, how the well the prediction is are, are they with respect to the actual values. So for this we will use something called as confusion matrix. So for that, to find confusion matrix, we'll use sklearn from sklearn import matrix and matrix.confusion matrix. We have to provide only two values, that is y-test and y-pred. It will compare these two values and it will and we are showing a CNF matrix. So it turns out to be, it will give something like 115, 10, 25, 42. So to know that what exactly it is, I created a heat map here. So let me do this. So to make a heat map, I will be using SNS library and the matplotlib. So to create a heat map, I will take the matrix value as data frame. I will take all the annotations and certain other parameters, and then I will give the label as set axis set label position at top, and I will give the tight layout. So based on this, it will, based on the CMap value, it will provide me this heat map thing. So here now we have to, now I will tell you what exactly it means like. So let me take another text here. Okay, so on the top, on the, you can say as a x-axis, you can take it as a predicted label. On y-axis it's actual label. So here what is actually happening is, if my actual label is 1, that is if I am diabetes, so with respect to I am diabetics, how many times the predicted value predicted labels is identifying it as correct. So let's start with 115. So 115 will come for predicted label as 0, predicted label 0, and I am taking 115, right? So actual label is here is also 0. Actual label is 0. So it turns out to be true negative. Okay, so true negative, that means actually it is I'm the value of that particular person given a value is actually 0, it's not diabetic, and the prediction value is also is not diabetic. So for this we are giving it as a true negative. So whenever we see any value, our attention should be on the diagonal value, that is here in this case 115 and 45. So for a 25% of the test value that I'm having, in which one for 115 samples, I found that it is correctly predicting that a person is not a diabetic person. Okay, so that is one. Then we have something called 10 on top right. So 10 here, in this the predicted value is 1, but actual label is 0. So in this case we are telling that predicted label is 1 and actual label is 0. We call it as false positive. False positive means in reality the person might not be diabetic, but the model is giving them as a diabetic signal. So it will consider as a false positive. So that's why the top right will be, in this case, in 10 instances, it is finding that the person actually is not diabetic, but it is still predicting as diabetic. Now 25, that is bottom left, it's 25. So let's see what is right. So predicted label is 0 and actual label is 1. So that means the actual label is the person is actually diabetic, but the prediction is telling that it's not a diabetic. So we call it as false negative. So it's negative in a sense that the model is saying that it's not a the person is not has diabetes, but in reality it has diabetes. That's why it's called false negative. And the last is when I have a predicted value label as 1, and actual label as 1 as well. So we call it as true positives, which means that the person is actually diabetic and the prediction is also saying that it's actual diabetic. So in this case, in 42 instances, it is finding it out. So this is a confusion matrix we are finding out. So here in 150 instances, it's correctly predicting that a person has not diabetic, and in reality also it's not diabetic. In 42 cases, it's telling that the person is actually diabetic, and this also prediction is also saying that it is diabetic. In the rest 35 cases, it is telling that it's not diabetic or actually diabetic, but in case the situation is vice versa. Okay, so this is our confusion matrix. Now one person has asked for 3 class confusion matrix. That means in this case I have to this is a multiple variable matrix. We can create 3 class also. Maybe in next class, based on the question that I am having and values I having, I can explain it much better. So next class I will show the 3 class confusion matrix for sure.
Sir, one more doubt, sir.
Yeah.
So if I change the label, predicted label is column wise to the row wise, there is any change in that?
No, values will not change.
Value. But
It's just a representation. You can do predicted levels row wise and actual levels column wise. That is doesn't matter because values are being calculated before. This presentation is we can differ anyway.
there is any change in that value?
Values will be rearranged. Means if instead of predicted value I'm having actual label here and predicted label here, then my values will shift. Maybe 115, maybe in this here instead of here I might find in the place of 42, and 42 might replace to in the place of 150. The values only the position will change, not the exact values.
Okay. Thank you.
Yeah. Okay, so there are other few metrics, typical famous metrics which we see. So which are using classification report from sklearn metrics.import classification report, we can find those values. So there's something called as precision, recall, F1 score, support, accuracy, macro average, weighted average. Multiple things are there. If we haven't went till that lectures, you can check it out. Otherwise uh, in the next session I will take actually more this kind of questions where we have to predict certain things using multiple regression models or classifier models. So I will do that, and that place I will explain exactly what they are, but in short I will explain what they are exactly. So the recall is okay. So recall tells that from all positive classes, how many prediction are correct, so are actually correct. So for this the formula is just I have said like to give something like true positive, that is true positive will be TP, let me write, it will be TP, false negative will be FN, false positive will be FP, true negative will be this. So okay, so the recall is actually calculated as TP by TP plus Fn. So it is true positive by false negative. So what it tells that from all the positive classes that we are doing how many prediction are actually correct. So we are actually, in this case, we are focusing on 115 and 42 values, that is diagonal values, that how many times we are actually from false sorry, I'm wrong, from 25 and 42. So the actual label is 1 here. If you see, the actual label is 1, but in 25% of the cases the model has incorrectly identified that thing, and 42% of the cases correctly identified it. So recall will be is that 42 divided by 25 plus 42. So that's a recall. So again, from all the positive classes, that is the in the actual values, in this case 1 here, how many are prediction are actually correct. So we do by TP by Fn. There is something called as precision. The next term is precision. The precision is from all classes that we have predicted as positive. That is, it has a diabetes, like that. Positive is, in this case, is diabetes. How many are actually positive? So precision will be true positive divided by true positive plus false positive. So in this case here it will be like, we'll focus on the precision will be on the predicted value of 1. So that is in this case 42 and 10 value. So 10 is false positive. That means even though actually the person is not diabetic, but the model has predicted that the person is diabetic in 10 instances. So it's considered as false positive. And we have true positive where the person is actually diabetic and predicted values also is considered as a diabetic. So we have precision as TP by TV plus Fn. So we just checking that of all the prediction which the model has given as a positive, in reality how much are actually positive. So this is one. And then we have something called as F measure. uh, F measure is basically a harmonic mean of precision and recall. So F will be like 2 into recall into precision divided by recall into precision. So there is something called as harmonic mean. So using this we can find the F score. F score considered to be more reliable compared to recall and precision. And then there's some, finally we the most used metric is accuracy, which tells that number of from all classes, whether it's positive or negative, positive and negative, that is correctly predicting that the person is diabetic, or it's correctly predicting that the person is not diabetic. So in this, for all the classes, how many of them the model predicted correctly. So in this case, like it's the value is 0.82. So it is like for 82% of the time it has actually corrected properly corrected the value. So how you can identify is you can add up these values 115 plus 42 and divide by all over the values, like 115 plus 10 plus 25 plus 42. The answer mostly will be 0.82. Okay, now here in the classification report we have given the precision, recall, F1 scores and support. Support is basically the true responses of the classes. So we will say that we will just look at the column here, in this case 25 and 42. So support of without diabetes, a person is without diabetes, is in the actual label is 115 plus 10, is that means in 125 instances the person is without diabetic. And in support of 67 with diabetes, we are looking actually that 67 people in that test data is actually diabetic, so that support is given here. I will tell you the most significant support in the later the next sessions. So with two classes with diabetes and without diabetes. We have calculated precision recall, F1 score, and all that. I'm not going towards the mathematics behind it right now. Maybe next lecture I will go. So these are the few important metrics, that is precision recall, F measure, accuracy. Then there's something called as ROC, AUC. We will mostly discuss that in next lecture. ROC and AUC as well. And we will mostly taking more machine learning kind of problems. Maybe I might able to solve one problem only, but I will solve it properly using one classifier or regression model. I will focus on that. Okay, so almost the classes time is up. So in this session, we have solved only three problems using coding. First is linear regression using the method linear regression using the method Hauser has proposed in the classroom, on which we have find the linear regression equations like this using this OLS library, sorry, OLS function, and then we have created the linear regression model as well using sklearn library. Similarly, we have discussed for multiple regression also with the same methodology. In logistic regression, we have tried to build uh, in logistic regression, we have tried to build a logistic regression model with the data we are having. We are not calculating any regression function values and all that. Using sklearn, we are only doing that, and with that, in that, we are using train and test method. That is, we are dividing the data of some parts into training and some part into testing, and then based on that, we are training a logistic regression model. And based on that, we have seen the confusion matrix, which tells about the performance of the model. So in that performance of the model, we have few terminologies, that is true, negative, which is tells that if in this case, if the person is not diabetic, whether the model is predicting that it's a non-diabetic or not. Then we have seen true positive. If the person is diabetic, then the model, whether the model is predicting it as a diabetic or not, it comes at true positive. False positive is the person is predicted as diabetic, but in reality he or she is not diabetic. So for that, this is false positive, and false negative will be the person uh, the person is actually diabetic, but the model is representing it as a non-diabetic. So these are four terminologies, and based on these four terminologies, we calculate precision matrix like precision, recall, F score, support, and accuracy. Okay, in the next class, I will mostly, as some few people have suggested, that I will talk about the residual plots also, and the three class confusion matrix as well. Okay, so that's the end from my side. If anyone has any question, please let me know.
Sir, this collab link, can you share again?
Collab link. Okay, just a minute. I'm sharing both Google Drive and Collab link. In Google Drive, I have the files. Sorry, in Google Drive, I have the files, and in Colab, we have the code here.
Sir, and the earlier question that is stop for there is
Yeah, I will change those. I will check what is the problem with that after this
no, sir,
session.
I found that
Mm-hmm.
there is a X train and Y train.
Mm-hmm.
Actually, there is a X train and X test should be there.
X test.
Yeah. So
Uh,
can you share again the screen?
just a minute. Mm-hmm. X train Y, but why we have to put Y test there? Because ideally, for a x train value, for x train whatever the values we are having, we have a corresponding y values, and that y values we are putting in y train. So ideally, if you give y test, the the answer should be wrong, because the number of samples will be deferred there.
In my system, it was run successfully.
Okay, let me try one more time.
Can I share my screen?
Yeah, you can share the screen. No, for me the input variable is inconsistent with the numbers it is showing. Okay, so might be okay, so X train X test and then Y train Y test.
Yeah.
Okay. Okay, I will check that. Just a minute. Okay. Yeah, correct. I have written it wrong. Okay, let me share the screen in that case. Yeah. Thank you for identifying this. So X train and then we have Y train. Then it should work, right?
Yes.
Oh, sorry. Y train. Yeah, now it's working properly fine. Okay, I will add the other part of the code here as well, and I will share that with you after the end of the session. Let me stop the recording as well. Okay, so ML question image recognition. Okay, I am not going to do any computer vision or email recognition. I will mostly doing with the typical numerical data that we are going to have. So I'm not going to do for image recognition. If I just check, I'm just going to check that with the course content. If they're using some image recognition, then I will do that. But I think most of the course is will be around uh, this thing. What do you say? The numerical values. Okay, recording link. Okay, so what you can do is right now I'm going to upload this thing in YouTube. You can check my recordings in the NPTEL tab. There, earlier recordings. In that, you can go to my channel and then from that you can check it. Right now, I will stop the recording and I have to upload it, so it may take half an hour time. So, if you want to see that, go to the earlier recordings of that. Earlier recording link if you want. Okay, then give me a minute. I have to open my YouTube channel. Just a minute, I'm just giving you. Okay, I'm directly giving a channel link. There you will eventually find it. The earlier recording links and this thing will be uploaded maybe in a half an hour or after 1 hour. Oh, I just put that thing. Yep. Okay, I've given the channel link. So after this, I will upload this. So any other question? So in that case, I will end the today's meeting. Let me stop the recording once again.